Okie dokie. So one thing I'm always gonna have handy for tomorrow is my chart. So I did post another updated version in your Google Classroom, just in case you don't have one handy. I have them in class too if you ever want a hard copy. This one I did have the rating column filled in, so on the other one we had kind of done that, but if yours, you never filled it in or it just wasn't neat or you just want a nice beautiful one, there you go. So it's in your feed, your Google Classroom feed. So what we're gonna do and what our main goal kind of always is can we isolate that trig function, whatever it is, in this case we have cosine, so then we can use our charts to find the actual answer. So, yes, we can do that. So we have a 3 right in front of cosine that's connected with multiplication, so we're gonna leave that as the second step. What we always do is go to the constant first, aka the number that's by itself first, if you have this set up, and we're gonna move that. And the opposite of -2 is +2. Okie dokie, so we get 3 cosine theta equals -2 + 2 is 0. Please don't, like some people get into the habit of being like that, and then like you just have nothing. Just write 0, right? If you have nothing left, 0 is a good representation of that. And then we would divide by 3. But hopefully we know when I divide 0 by anything, no matter what it is, my answer is just gonna be 0. So just as a reminder, I feel like sometimes we tend to be like, oh sweet, like I solved it, I'm done. You're not done until you use your chart. So have it, love it, find the answer. So cosine theta equals 0. I literally go to the cosine column. I'm gonna follow it down and find zeros, and I'm gonna give the answer in degrees. So I go down 0 at 90 degrees, and we have a 0 at 270 degrees. And that would be your final answer for that one. Come on, I'm gonna kind of give you a minute. Like, let's be honest, it's Monday morning, we're all struggling at this point. But I do expect you to write that down. I will be checking everyone's notes at the end. Because we all know if I say I'm not checking them, you won't do it, so. I'm just writing this down for next period. I have them on my computer, but it's easier if I write. Sorry, I can move on to Veil. Okay. All right, so that was 1 in degrees. I'm gonna do the next one in radians, which we know hopefully doesn't actually change any of the steps, which is nice. So just let me know if you have questions as we do things. So I'm gonna erase this one. I'm gonna say for the next one, I'm gonna want the answer in radians. So as you're taking the little thing tomorrow, just pay attention, because if you do it in the wrong thing, am I gonna give you most of the credit? Sure, but I might take a point off or two for just not reading directions. So I'm never gonna say like, you got it completely wrong because you did something little wrong, but. All right, same type of problem. We'll look at a few other setups in a second as well. But the main idea is, okay, we want to get our trig function by itself. In this case, we do have cosecant, so that's exciting. A little bit of a different function. But the solving is kind of the same. I have -3 out in front, which is connected with multiplication, and then I have +4. So we're always going to move the constant, so the thing that's by itself first. So the first thing I'm going to do is subtract 4. Just like solving a good old equation, like solving for x. Ooh, I still want to get cosecant by itself. So my next step is I'm going to divide by -3. And once again, at this point, I'm like feeling good. I'm like, okay, like sweet, I've solved it. I'm good. But we're not at the final answer until we use our chart. So in the chart, I go back, I just make sure I'm looking in the cosecant column for 2. Okay, I can do that. That's not a problem. Just make sure your answer is in radians. So that's a big thing. And my final answer would be pi over 6. And it would also be 5 pi over 6. So a lot of the same steps as the first one, kind of just some numbers change. You're using a different trig function. That just means you're using a different column. And just make sure your answer is in the correct, whether it's degree or radian. Sorry, give me 1 second. I'm trying to find a beautiful one. Distributing, and I cannot do it. Okie dokie. Oh, what's the one? Oh, just now. Oh, okay. So the next one, I'll keep it in radians, so I don't keep going back and forth, but usually I'll just put them in kind of sections. So just make sure you read the direction of each section. So I'll keep this next one in radians. I just have 2 more to kind of do with you just to see some different setups. And I'm going to have you guys just try 2 or 3. So I just wanted to remind you what to do if you saw your trig functions kind of happen more than once in your equation. So I'm kind of, once I see a bunch of stuff going on, I'm more visual, so I just remind myself, okay. On the left side, I have cotangent theta. On the right side, I have 4 minus 3, and I have another cotangent theta, so we just want to make sure we know how to kind of remedy that. So what we do is we want to get our cotangents together. To do so, go to one side. I usually tend to move the cotangents to the left. It doesn't really matter though. And I'm going to say, okay, I have minus 3 cotangent theta. How do I move that? Well, the opposite of minus 3 cotangent theta is plus 3 cotangent theta. So if I would just want to kind of take that, pick that up and move it, I just use the opposite sign. If it's negative, I'm going to add it. If it was positive, I would subtract it. So the reason I do that is so I can get the cotangents together, and now I can add them. Remember, if I just have that, I can put a 1 in front of it. So 1 plus 3 gives me 4 cotangent theta equals, and remember the only thing left over here is 4. So that's really just kind of moving stuff around. Now we can solve, because our last step is to get rid of that multiplication in front. And we end up with cotangent theta equals 1. Once again, a lot of times we feel like we're kind of done because we solved it, but we grab our chart, we know we're not done yet. I'm going to give this answer in radians. And what do we got? I go down my cotangent column, I find 1. It happens at pi over 4, since I'm using radians. And cotangent also equals 1. Oh, well, that's 5 pi over 4. So just make sure you're okay with that one. And I just have one more one I wanted to show you. I'll do this one in degrees. Sorry, I'm just writing them for my next class, so I do the same exact ones. Let's do. Let's do you good. I don't know. Sorry, I want to do one that's a little different, just so if it does pop up, you've seen it. Sine. Nope, I don't want to do sine yet in that bag. I want to do secant equals, and then we're going to equal it to. Actually, that's not going to work. Never mind. We'll just make it a little funky here. Secant theta. Okay. I think that's gonna work. Let me just check myself quick. Okay, should work. That's how it works. Okay, I'm gonna flip myself. So this is the last one I really wanted to show you. And then I actually wanted to show you something with the things you guys were doing. I'm gonna flip this to degrees. Once again, usually I'll just kind of put them in 2 sections, so just read your directions. Let's say something like this. I just wanted to remind you what to do if you saw parentheses like that. So the big thing here is you are going to be distributing. So good old distributing back from your algebra days. So when I distribute that in, I would get 5 secant theta plus 5, right? Because 5 times 1. On the right side, I'm going to distribute in and I'll get 4 secant theta plus 4 times 1 is 4. Okay, so I'm feeling pretty good. I kind of just visualize my sides. My main goal is to get my secants together. So that's always what I want to do first. That's what I'm solving for. So pick a side and move it. I'm going to move this one. I want to pick this up and move it over here. And I do that by using the opposite side. Since this is positive, I'm going to subtract it. Okay. Ooh. So we end up with what? Just secant theta, because 5 minus 4 is 1. So I can just write that as secant, or you can put the 1 in front if you like. Excuse me. And then to get secant by itself, I'll just subtract 5. Secant theta equals -1. I grab my chart, so that's always my main goal where I'm getting my final answer. I just remind myself, okay, this is going to be in degrees. So that's not too bad. Go down the secant column. What about for -1? That happens at 180 degrees, and that's it. So I feel like a lot of times we're used to finding 2 answers. Sometimes there will only be 1. So if you just get 1, it's not a big deal. It usually happens when you're at that 180 degrees / pi angle. Yep. Okay. Just wanted to make sure that was good. So basically, if you've kind of followed along with those 4, you are in good shape for tomorrow. So I'm not. My main goal is to really just kind of cruise into, what is it, I think it's 61 days, maybe, or 60. Our last 60-something days here. But with that, I still need to kind of give you a grade, so I'll give you little things here and there, but nothing too crazy. So just probably a few degree problems, a few radian problems, which we see are pretty similar to each other. So that was that. I'm going to give you 2 wrap-up problems in a moment. I just wanted to do one thing quick, and that one thing, oh my God, the one thing I wanted to do is find that assignment you guys were doing last week. What was this? So it turned out I was absent one day, and then a lot of you had an issue or 2 actually doing it. So Friday you kind of finished that up. I just want to give you the answers to them, because what's the point of what's the point of doing something and then not knowing if you did it right? That's not very helpful. So I'm going to upload those now. Give me 1 second. I just need to save it as a PDF so you can actually see it. That's for the material. So that's another thing. And once again, like if you're not checking it right now, that's okay. Like I don't even expect you to check it. But tomorrow, when you're like, oh, I don't remember how to do this or whatever, use it as a resource. So my main goal is to just give you as many resources as possible, so you can use them to your benefit. So solving Trig equations worksheet. Sorry if I don't do it right now, I will forget. Answer key. And this will be up for everyone. Sorry, I really kind of hate Google Classrooms. It's like a 25-step process to do anything. There we go. So I want it for A and B. The topic. Oh, it's a new week. Week of 3. Exciting stuff. Post. It's taking forever. There we go. Okay, so now on your Google Classroom for everyone. So even if you're in class, I'll kind of let you use that tomorrow. On Thursday/Friday, you were working on just like a little worksheet, but now all the answers are up. So even if you don't go right now and check them, that's okay. But tomorrow, as you're taking your little mini assessment, you're like, oh man, there was one I did like this last week. Let me just check it, because now the answers are there. So just as a heads up. So that is up for you. Just, once again, the more resources you have, the easier your life should be. Okay, so now I'm going to put up our 2 wrap-up problems, because then that will give people a little bit of time. Just like every day, I'm going to, once again, make my life a little bit harder. Sorry, I keep forgetting to set up my Google Classroom. So I'll just say, assessment, review, wrap-up. So I'm putting something in Google Classroom, so when you're done at home, you can upload your work. Today is the 1st week of 3. Okay, so that's posted right now. So once you're done, please upload those by the end of the period. So none of this, like I'm gonna do it 4 hours later. It's 2 problems. So you can do it in the 20-minute time span and get it submitted. So here are your wrap-ups. And the people here, I'll just check yours, so just don't put them away. Or when you're done, you can just show them to me, that's fine. Numero. Sorry, to make sure. To give myself some nice problems. All right, let's do root 2 plus 2 cosine theta equals 0. So this had happened last week as people were kind of working. Don't get freaked out with radicals with the square roots. Just kind of move them like you would a normal number, right? So this is we call it the constant by itself. If it's square root of 2, you just would do minus square root of 2 and you'd kind of move it and then see what happens. But I just wanted to remind you, radicals pop up. You just kind of move them like you would a normal number. I'm not going to put anything crazy with kind of combining stuff. And for this first one, I want your answer in degrees. And then we'll do one more. And let's do, we'll do sine theta equals 2 sine theta. Actually, don't look at this one yet. I'm making this enough as I go. Just check that makes sense. Okay, that should make sense, and that will be a radians. Okay, so number 1, just kind of moving stuff around. Number 2, you have some distributing, and then you will see your trig function on both sides. So what do you do from there? So can you work on those for the next few? We are going to go over these before you leave. So upload them as you go, but then just hang on. I'll just give you like 5 minutes. I'm not going to keep you on for the next 15. Because I just want to check them quick before you leave to see if there's any questions and to make sure you're doing them correctly. And we shall go from there. All right, so for these 2, I say degrees. I'm just going to erase it so I can actually do my work below it. So I'll just put up here degrees. So once again, it's just kind of about moving stuff around to get cosine isolated. So in this case, I am going to subtract root 2. So don't have a heart attack if you have to do stuff with radicals. There's not going to be a ton of like combining or stuff like that. Maybe just moving from one side to another. So that gives me negative root 2. And then I'm going to divide. And I end up with cosine theta equals negative root 2 over 2. And then remind myself I need to actually find my final answer. So I go down my cosine column, I look for negative root 2 over 2, and I give my degrees. It should be 135 degrees, comma. I'm in the wrong column, so that's exciting. 225 degrees. Please, if it's a degree, put a degree symbol. Yes, yes. But that should be your answer to those two. And then our other number 2 here, I'm just gonna once again, so I want to be able to actually do the work here, so I'm gonna just remind myself radians. So I see distributing on the right side, so I'm gonna do that first. So if you can distribute, always do that as your first step. And I kind of think, oh, well, I got a sign on the left, I got a sign on the right, I got to move stuff together. So I'm going to move this over here, because if not, then there'll just be nothing on my left side, and that'll be kind of annoying. If you move a little differently, we should still get the same answer. So just be careful there. Remind yourself that's 1 minus 2, which gives me negative 1 sine theta. That's going to equal 2. And then last but not least, we would divide both sides by negative 1 because we just want sine. We don't want negative sine. Oh, shoot. Mrs. Sherman. And there's nothing that has that because I'm a doof. And in my head, that was backwards. Oh, gosh. Sorry. That was supposed to be negative 1/2. And my brain was working backwards this morning. And when you looked in the sine column for negative 2, it does not exist. So that one, sorry about that. Was my fault. That's what happens when Mrs. Sherman goes crazy on a Monday morning. I'm so sorry about that one. So if you were doing number 2 and saying, oh crap, I don't know what the answer is, you were correct. Your answer was there is no answer because Mrs. Sherman's brain was not working this morning. So I did it like 3 times and in my head the answer was negative 1/2 and I was obviously not functioning. So good for me. There we go. So I won't write the other one, so I totally did that one correctly. Good for me. I'm going to stop this.